Hey guys, in this video we're going to learn about the properties of a trapezoid and a little something about its midsegment. Alright, so a trapezoid falls under the quadrilateral family, and specifically it's a quadrilateral with exactly one pair of parallel sides. Okay, so here's our trapezoid, or our quadrilateral I should say, and the sides that are considered parallel are called your bases. So we have base number 1 and base number 2, and those two sides of the quadrilateral are parallel. So those are called bases. Now the two remaining sides that aren't bases are called legs. So we have the first leg on the left and second leg on the right. And these are the names of the sides of our trapezoid. Now an isosceles trapezoid is a trapezoid, however the legs of the trapezoid are congruent. So let's draw another trapezoid where our bases are parallel to each other. And now the two remaining legs, or the two remaining sides I should say, are congruent. This is an isosceles trapezoid. Now, there are also angles inside of the trapezoid that have specific names, and those are called base angles. So, the first property of the angles inside of the isosceles trapezoid are the base angles. So, if a trapezoid is isosceles, then each pair of base angles is supplementary. Okay, what that means is that if we have a trapezoid, isosceles specifically, we know this trapezoid is isosceles. Let's just take away these little little congruent marks real quick. So if we have a trapezoid that we know that the bases are parallel, and we name it RSTV, then each pair of base angles is supplementary. So I'm talking about one base angle. So these are called base angles. So we have one pair V and T and another pair R and S. If you take one angle from one pair of base angles and add it to the other pair of one angle from the other pair of base angles, those are going to be supplementary. So angle R plus angle V should equal 180 degrees. So this is a pair of base angles, but if you take one angle from each pair, then they're going to be supplementary. So if you know that they're supplementary, then we can conclude that this is a isosceles trapezoid. Another property about the base angles of an isosceles trapezoid is that if a trapezoid has a pair of congruent base angles, then we know it's an isosceles trapezoid. So let's draw our trapezoid. Okay. So then our base angle pair, number 1, are located on the bottom, and then we have another pair located on the top. So if we have a trapezoid when we know that the base angle pairs are congruent, so the two bottom ones are congruent to each other, and the two top ones are congruent to each other, then we know it's an isosceles trapezoid. Alright, we got a typo real quick, so make sure you change this word that used to say triangle to trapezoid. And going back to the base angles really quick, we're talking about the base angle pair being congruent to one another. So then these two angles are congruent, and then these two bottom base angles are, are congruent. Alright, so the last property with the isosceles trapezoid is about the diagonals, and if a trapezoid is isosceles, then, cross it off and write down, then the diagonals are congruent. So let's draw a trapezoid and label the vertices A, B, C, D. So if we draw a diagonal AC and draw another diagonal DB, those two diagonals are congruent to one another. Alright, in example 1 we have to find the angle measurements. So we have to find the measurements of angle C, angle A, and angle D with the trapezoid shown. So if we look at the trapezoid alone, we notice that AD is parallel to BC with the two arrowheads, and we also know that the two tick marks marking the legs congruent. So this is an isosceles trapezoid. So we have to think of the properties of an isosceles trapezoid that we've just learned to figure out what the measurements of these angles are. So we have a pair of base angles. We know one angle is 135, and one pair of base angles B and C are going to be congruent in an isosceles trapezoid. So right away, angle C is 135 degrees. Okay? So then using that knowledge that we have a pair of base angles that are congruent, now we know that each pair of base angles, so from B and D and B and A, those are supplementary. So if we know that we have two parallel lines cut by transversal, how that works is that we have two angles on the same side. These are consecutive interior angles, and that's why these two angles, each pair of base angles, are going to be supplementary. So then if you take angle D and you take 180 degrees and subtract 135 from it, we can figure out what the measurement of angle D is, because they're supplementary. So then 135 plus 45 will give you 180, so then 45 degrees is angle D. And then since we're going back to the first property we talked about, the base angles being congruent, angle A is also 45 degrees. So angle D is 45 degrees and angle A is 45 degrees as well. Alright, so the last property is the mid-segment theorem for trapezoids. And a mid-segment, or the mid-segment of a trapezoid, is parallel to each base, and its length is half the sum of the bases. So I'll talk about what this means in the next example. So the mid-segment of a trapezoid is parallel to each base, and its length is half the sum of the lengths of the bases. So in this diagram right here, we have a trapezoid, and we know that this MN right now, well, we will know that this is the mid-segment. And the mid-segment is going to be parallel to each of the bases. Okay? So then if we have to figure out the length of MN, well, going back to our previous slide, we know that the mid-segment is half the sum of the lengths of the bases. Okay, so then if we know that it's half the sum of the lengths of the bases, MN is equal to 1/2 the sum of PQ and SR. So luckily we know the lengths of the bases, and we're just trying to figure out the mid-segment length. We substitute in our values that we know for the bases as 1/2 times 16 plus 9, 1/2 of 25, so the mid-segment length is 12.5 inches.